Hi, this is JJ Singh from Parts Up University, and we continue on with the textbook Elementary Algebra by John Redden. And now we start Chapter 2, beginning with Section 2.1, Introduction to Algebra. Chapter 2 is called Linear Equations and Inequalities. So, Section 2.1, Introduction to Algebra. We're going to identify an algebraic expression and its parts. We're going to evaluate algebraic expressions. And we're going to use formulas to solve problems in common applications. What that means is you'll find out soon enough. Okay, so let's kick it off with some definitions. We use letters to represent numbers, and these letters are called variables. You may have heard of X and Y. X and Y are very commonly used letters representing numbers. Okay? So combinations of variables and numbers along with mathematical operations form algebraic expressions, which you can just refer to as expressions. And the following are some examples of expressions using just one variable, x. Okay, so here we're not using y, we're just talking about x. 2x plus 3 means you're doubling whatever x is, and then you add 3 to whatever that doubling becomes. So if x is 4, 2x is 2 times 4, which is 8, and you add 3 to that, which is 11. Okay. Now here's another expression, x squared minus 9. Again, let's use x being 4. So x squared becomes 4 squared, which is 16, and you subtract 9 from that, so you end up with 7. And here's some expressions that are a little bit more complicated. 3x squared plus 2x minus 1, and another one which has a numerator of x minus 5 and a denominator of x squared minus 25. So, what are terms? Terms in an expression are separated by addition operators, and factors are separated by multiplication operators. So in the expression 2x plus 3, 2x is a term, and 3 is a term. Okay? Now, factors are separated by multiplication operators. So in 2x plus 3, the factors are 2 and x. They're being multiplied. The numerical factor of a term is called the coefficient. So in 2x plus 3, the terms are 2x and 3. The factors are 2 and x, and the coefficient is 2. In another example, the expression 3x squared plus 2x minus 1 can be thought of as 3x squared plus 2x plus negative 1. So it has 3 terms, those terms that are being added up. In one case, it's a negative number being added, which is the same as a positive number being subtracted. The first term, 3x squared, represents the quantity 3 times x, where 3 is the coefficient and x is the variable. All of the variable factors, with their exponents, form the variable part of a term. If a term is written without a variable factor, then it's called a constant term. So let's consider the components of 3x squared plus 2x minus 1. What are your terms? Well, you got 3x squared, you got 2x, and you got negative 1. So in the first term, the coefficient is 3, and the variable part is x squared. In the second term, 2x, the coefficient is 2, and the variable part is x. And in the last term, the coefficient is negative 1, but you have no variable part. Okay, so that means it's a constant term. The third term in this expression, negative 1, is a constant term because it's written without a variable factor. While a variable represents an unknown quantity and may change, the constant term does not change. Negative 1 is always going to be equal to negative 1. Here's another example. Let's say we have 5x squared minus 4xy minus y squared. So we'll think of the third term in this example as negative 1y squared. Okay? There's a 1 being multiplied by y squared there that we don't indicate in writing because 1 times something is just that something, right? But in this case, just to make it more obvious what the coefficient is, we're going to write it as negative 1y squared. So the terms are 5x squared and negative 4xy and negative y squared. So what's the coefficient of the first term? First term is 5x squared, coefficient's 5, variable part's x squared. The second term is negative 4xy, the coefficient's negative 4, the variable part is xy. Now notice that in the variable part you can have two different variables being indicated. Okay? And the third term, which is indicated as negative y squared, but we're going to refer to as negative 1y squared. The coefficient is negative 1, and the variable part is y squared. So, the coefficients, if we're going to line them up from smallest to biggest, are negative 4, negative 1, and positive 5. The variable parts, if we're going to line them up in decreasing order of x and increasing order of y, I don't know if I've actually expressed that correctly, but anyway, we're lining them up with more power to the x at the beginning and more power to the y towards the end. So x squared, xy, y squared. I'm sorry, I'm not speaking that well today. Those are the variable parts. Some terms, such as y squared and negative y squared, appear not to have a coefficient. The multiplicative identity property states that 1 times anything is itself, and occurs so often that it's customary to omit this factor and write 1y squared as y squared and negative 1y squared as negative y squared. Therefore, the coefficient of y squared is actually 1, and the coefficient of negative y squared is actually negative 1. You'll also encounter terms that have variable parts composed of algebraic expressions as factors. Okay, and we'll talk about that in a second. Terms that have variable parts composed of algebraic expressions as factors. Okay, so list all the coefficients and variable parts of each term. And here we have negative 3 times x plus y quantity cubed plus x plus y quantity squared. Okay, so this is an expression with two terms. The first term is negative 3 times x plus y quantity cubed. And the coefficient in that term is negative 3. The variable part is x plus y quantity cubed. The next term is x plus y quantity squared. The coefficient is 1, which is omitted like we normally do when something's multiplied by 1. So that's 1. And the variable part is x plus y quantity squared. So the coefficients are negative 3 and positive 1, and the variable parts are x plus y quantity cubed and x plus y quantity squared. In algebra, we'll encounter a wide variety of expressions. Typically, expressions use the two most common variables x and y. However, expressions may use any letter or symbol for a variable, even Greek letters, such as alpha and beta. Some letters and symbols are reserved for constants, such as pi. Pi is a constant, which is approximately equal to 3.14159. And e is a constant, which is approximately equal to 2.71828. Since there's only a limited number of letters, you'll also use subscripts like x1, x2, x3, x4 to indicate different variables. So, here's a question. List all coefficients and variable parts of the expression negative 5a squared plus ab minus 2b squared minus 3. Okay, now the answer's here. Maybe we shouldn't be showing you the answer when we're actually still working on the question. I can't actually avoid showing you the answer. Okay, well that's all right. Let's look at the terms. The first term is negative 5a squared, which has the coefficient negative 5 and the variable part a squared. The next term is 1ab. Okay, we're putting that 1 in where it had been omitted before. Coefficients 1, variable parts ab. Next term is negative 2b squared, coefficients negative 2, variable parts b squared. Next term is negative 3, and that's a constant. So it has the coefficient negative 3, doesn't have a variable part. So the coefficients that I just mentioned are negative 5, positive 1, negative 2, and negative 3. And we can line them up from smallest to biggest as negative 5, negative 3, negative 2, and positive 1. The variable parts, as I just mentioned, are a squared, ab, and b squared. Remember the fourth term didn't have a variable part because it's a constant. Now, evaluating expressions. Think of an expression as a generalization of particular arithmetic operations. Performing these operations after substituting given values for variables is called evaluating. A variable represents an unknown value. But if the problem specifically assigns a value to the variable, then you can replace that letter with a given number and evaluate using the order of operations. So, let's say you have the expression 2x plus 3, and you want to evaluate it where x is equal to negative 4. You just substitute in negative 4 for wherever you see x, okay? So here you have 2x plus 3 equals 2 times something plus 3. That something is negative 4. So 2 times negative 4 is negative 8. Add 3 to that, and you get negative 5. Here's another example. The expression is 2/3 y, where y is equal to 9. So 2/3 times y equals 2/3 times something. That something is 9. 2/3 times 9 is 18/3. Or another way of saying it is 2 times 9 over 3, which is 2 times 3. So that's equal to 6. If parentheses are not used in part A of the previous example, the result is quite different. 2x plus 3 is equal to 2 minus 4 plus 4. Without parentheses, wait a second. I don't think this is stated correctly here. Oh, that's just if you're not paying attention and you forgot to put parentheses, then you're going to screw everything up, which makes sense. Okay, that's all that's saying. So let's evaluate negative 2x minus y, where x equals negative 5 and y equals negative 3. Okay, so we have negative 2 times something, which is x, minus something, which is y. So negative 2 times x is negative 2 times negative 5. Negative 2 times negative 5 is positive 10. And then after that, we want to subtract y. From that, we want to subtract y. So we're subtracting negative 3, which means we're adding positive 3. So 10 plus 3 is 13. Evaluate 9a squared minus b squared, where a equals 2 and b equals negative 5. Okay, so 9 times something squared minus something else squared, where the first something squared is a squared and the next something squared is b squared. So 9 times 2 squared, well, what's 2 squared? It's 4. 9 times 4 is 36. From that, we want to subtract b squared. So we're subtracting negative 5 squared. Negative 5 times negative 5 is 25, positive 25. So we're subtracting positive 25 from 36. 36 minus 25 is 11. Evaluate negative x squared minus 4x plus 1, where x is equal to negative 1/2. Okay, here we're getting a little bit complicated now. So here we have 3 terms. The first term is negative something squared, negative x squared. The next term is negative 4 times x, and the last term is just adding the constant 1. So the first term, negative x squared, well, x is negative 1/2, so negative 1/2 squared is positive 1/4. So we have negative x squared is positive 1/4, or 1/4. So negative x squared is negative 1/4. Minus 4x, well, minus 4x is minus 4 times negative 1/2. So the negatives canceled. You get 4 times 1/2, which is 2. So that becomes plus 2. And then we also want to add the constant plus 1. So if we're adding plus 2 and then plus 1, we're just adding plus 3. So negative 1/4 plus 3 is, if you do the math, it's equal to positive 2 3/4. Let's just show you how it's done. Positive 3 is the same as 12 over 4, right? So negative 1/4 plus 3 is equal to negative 1/4 plus 12 over 4, which is the same as 12 minus 1 over 4, which is 11 over 4, 11 fourths. And that can be rewritten as 2 3/4. In algebra, improper fractions are generally preferred, as opposed to the mixed number 2 3/4, unless the original problem has mixed numbers in it, or it's an answer to a real-world application. Solutions will be expressed as reduced improper fractions. So that means leave it as 11 fourths. Okay, now we're going to evaluate the product of 3x minus 2 times x minus 7, where x equals 2/3. Okay, so here it's really the order of operations that's important. You got to remember that you have to solve what's in the parentheses first. If you follow PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So here you have parentheses and parentheses within parentheses, because you're dealing with variables, the variable x. Okay, so what do I mean by that? That means I want to solve 3x minus 2, and I want to solve x minus 7 before I think about multiplying 3x minus 2 times x minus 7. So 3x minus 2 is 3 times 2/3, which is x, minus 2. 3 times 2/3 is 6/3, or 2. 2 minus 2 becomes 0, right? So now, if this is 0, and I'm going to multiply 0 times x minus 7, it doesn't really matter what x minus 7 is. 0 times anything makes it 0. But just for argument's sake, let's say we didn't know that. We're going to solve x minus 7 while we're here. So x minus 7 is 2/3 minus 7. 7 is 21/3. So 2/3 minus 21/3 is negative 19/3. 0 times negative 19/3 is 0. Because 0 times anything is 0. Okay, evaluate b squared minus 4ac. This b squared minus 4ac is called the discriminant, and it's very important later on in our study of algebra. You'll see why it's important, but for now you can just think of it as b squared minus 4ac, where b, a, and c are variables. Okay, so in this case, a is going to be equal to negative 1, b is going to be equal to negative 3, c is going to be equal to positive 2. And we want to evaluate what b squared minus 4ac is. So b squared is negative 3 squared. Negative 3 times negative 3, negatives cancel, and that's positive 9. So we're going to have 9 minus 4ac. A is negative 1, c is 2. So minus 4ac is minus 4 times minus 1 times positive 2. Minus 4 times minus 1 is positive 4 times positive 2 is positive 8. Minus 3 squared was 9. 9 plus 8 becomes 17. Okay, here's another example. A cubed minus b cubed, where a is 2 and b is negative 3. Well, what's a cubed? It's 2 cubed. 2 cubed is 2 times 2 times 2, which is 4 times 2, which is 8. Okay? Minus b cubed. What's b cubed? It's minus 3 times minus 3 times minus 3, because it's minus 3 cubed. So minus 3 times minus 3 is positive 9. 9 times minus 3 is negative 27. So b cubed is negative 27. But we want to subtract b cubed. So if we're subtracting negative 27, that's the same as adding positive 27 to our value for a cubed, which was 8. 8 plus 27 is 35. So that's our answer there, 35. Using formulas. The main difference between algebra and arithmetic is the organized use of variables. This idea leads to reusable formulas, which are mathematical models using expressions to describe common applications. For example, the area of a rectangle is modeled by the formula area equals length times width. A equals LW, or A equals L times W. In this equation, variables are used to describe the relationship between the area of a rectangle and the length of its sides. The area is the product of the length and the width of the rectangle. If the length of the rectangle measures 3 meters and the width measures 2 meters, the area can be calculated using A equals L times W, which is equal to 3 meters times 2 meters, which is equal to 6 square meters. So, let's look at an example. Cost of a daily truck rental is $48, plus an additional 45 cents for each mile driven. This cost in dollars can be modeled by the formula cost equals 0.45x plus 48, where x represents the number of miles driven in one day. Use this formula to calculate the cost to rent the truck for a day and drive it 120 miles. Okay? So, x is going to be 120, right? Because that's the number of miles. Cost equals 45 cents times the number of miles, which is x, plus your constant of $48, which you have to pay no matter what. Right? So you're going to substitute 120 into the formula for x and then simplify. So here you have 0.45 times something, which is 120, plus 48, and you might need to get your calculator out here to figure out that, or use extra time to figure out that 0.45 times 120 is equal to 54. But just trust me that it is. And you add 48 to that, so you get 102. So the rental costs $102 if you drive 120 miles. Uniform motion is modeled by the formula distance equals rate times time, or some people say distance equals velocity times time. It's the same idea. Okay, so D equals R times T, or D equals RT. Jim's road trip takes 2.5 hours at an average speed of 66 miles an hour. How far did he travel? Okay, well his road trip took 2.5 hours. That's time. His speed, 66 miles per hour, is his rate or his velocity. Well, we're just going to say rate here because that's how this formula is defined. So we know what R is and we know what T is, and we want to find out how far he traveled, which is the distance he travels, which is D. So D equals R times T equals 66 miles an hour for 2.5 hours. 66 times 5 halves is equal to 33.5 miles. I'm sorry, 33 times 5. 66 times 5 halves is the same as 66 halves times 5, which is 33 times 5, which is 165. 165 miles is how far he travels. Okay. The volume in cubic units of a rectangular box is given by the formula volume equals length times width times height, where L represents length, W width, and H height. A wooden box is 1 foot in length, 5 inches wide, 6 inches high. Find the volume of the box in cubic inches. Okay, now when you have a question where it tells you to find the volume of the box and it gives you specific units of measurement, in this case cubic inches, then that's a hint to you that maybe some of the measurements you're starting off with are not in inches, and maybe you should convert those to inches just to kick things off with, so that later on your result will be in 1 unit of measurement. And as that hint would indicate, our length is 1 foot. That's not in inches. We have to know that there's 12 inches in a foot. So we're not going to use 1 foot as a length. We're going to use 12 inches as a length. 5 inches is a width. 6 inches is a height. Now everything's in inches. When we multiply inch times inch times inch, we'll end up with cubic inches. So volume equals length times width times height equals 12 inches times 5 inches times 6 inches. 12 times 5 is 60. 60 times 6 is 360. So our answer is 360 cubic inches. Simple interest. Interest, I, is given by the formula PRT, where P is the principal amount invested at an annual interest rate R for T years. So, what's the simple interest earned on a 2-year investment of $1,250 at an annual interest rate of 3.75%? Okay, we're going to convert 3.75% into 3.75%. And we're going to convert that into a decimal number before using it in the formula. 3.75% is 3.75 divided by 100, which equals 0.035. 0.0375. So interest is PRT. Principal is how much money you're investing. Okay, $1,250. Rate here is 0.0375. And time is 2 years. Okay. P is 1250, T is 2 years, R is 0.0375. So, interest equals 1250 times 0.0375 times 2. You're probably going to need a calculator here, and you'll get, as a result, $93.75. Okay. Now, here's a question. The perimeter of a rectangle is given by the formula perimeter P equals 2L plus 2W, where L is length and W is width. Okay, so 2 times the length plus 2 times the width. And if you look at it at a rectangle and you think about the perimeter, you think about just adding up the length of each of the 4 sides. So you'd add up length plus width plus length plus width, which is the same as 2L plus 2W. Use the formula to calculate the perimeter of a rectangle with a length of 5 feet and a width of 2.5 feet. Well, if length is 5 feet, L is 5, so 2L is 10. If width is 2.5 feet, W is 2.5, 2W is 5. So 2L is 10, 2W is 5, 2L plus 2W is 15. So your answer is 15 feet. That's a perimeter. Okay, so what did we learn here in this section? Think of algebraic expressions as generalizations of common arithmetic operations that are formed by combining numbers, variables, and mathematical operations. It's customary to omit the coefficient if it's a 1, as in x squared is equal to 1x squared. To avoid common errors when evaluating, it's best practice to replace all variables with parentheses and then substitute the appropriate values. The use of algebraic expressions allows us to create useful and reusable formulas that model common applications. So as usual, you have some homework questions that you can try doing. The odd numbered questions have answers for them available at the end. So try and do a couple of each type of question. And just do odd questions, I would say, so that you can look at your answers. You can look at the right answers.